This is an Impex HG100. It is a heavy-duty, low-velocity powder-actuated tool. Sometimes these tools are called medium-velocity tools. And in a nutshell, what medium velocity means is that it is at the high end of low-velocity tools. Moving a fastener any faster would mean that the tool would then be rated as high velocity. The designers of these tools implemented a lot of features in order to get as much power out of them as possible. First off, they are larger than most low velocity tools, heavier. Many of them have an accessory such as this one, a heavy duty spall reducer. The tool came with a smaller rubber spall reducer. And their main purpose is to suppress the spall when driving into concrete, but they're about 2-3 pounds, and it's also added weight in driving not only into concrete but into steel also. Many of these tools also feature a closed barrel, and the closed barrel basically means that there's no reset slot in it. They may be vented, they may have vent holes in them, but you'll see there's no reset pin here. And there's no large slot, so there's very little gas escapage. Also, these were known as dipstick tools. You would use a dipstick like this to push the piston and the fastener back. And these and a few other things would get more energy out of the tool to set the fastener. The Impex SG100 is one of my favorite tools to demonstrate when shooting into half-inch steel. It does a really good job at it. It's one of the few tools that really compare to the Hilti DX600. I'm going to take the barrel assembly of this thing apart. Show you some of the inner workings of it. Remove the barrel stop first. After I pop the barrel stop out, there's a detent ball bearing and spring underneath here. I'm going to want to grab it so I don't lose it. It's going to pop out here in just a few seconds. There it goes. It's just a 5mm ball and spring there. The ejector block here is also backed by a 5mm ball bearing and spring, and it's one of the more effective ejectors for ejecting spent loads in this fashion. The outer barrel is known also as a silencer, and that's what really quiets the tool down. It slips off the barrel here. And we do have vent holes in the barrel, so it does vent some of the pressure off. But most of the pressure needed to drive the fastener is going to happen in this area anyway, above the first vent holes. And this is the crush ring and the piston. And it looks like it's bent a little bit. Hopefully that's my imagination. How the crush ring works is inside this nose piece, it's concave down there. So if you overdrive the tool, the crush ring is going to strike the base of the nose piece, and it'll eventually cup and grab the piston somewhere along this length, and you won't be able to reset the piston anymore. At that point, hopefully you take the tool apart, remove the crush ring. There is a special tool. It's basically a conduit pipe, piece of conduit about yay long, to remove it. And hopefully you learn from that and what your mistakes are, and adjust yourselves to do a proper fastening without damaging the tool any further. Also, the nose piece is supported by a neoprene spring. Basically, it's a rubber tube. And that would be inside both the heavy-duty spall reducer and if it was just the collar alone. Both tools would have that spring in it. Now these barrels get damaged up here when you allow them, actually it's on this end, when you allow them to slip a lot, it'll dig up a burr here from pounding against the stop. And that can make the tool very difficult to remove. I have taken that off a little bit. I have filed that down from time to time in order to keep it moving. Also, if the barrel's not cleaned often enough, carbon will build up in these rings and it'll become extremely difficult to remove the barrel from the barrel sleeve. And go ahead and put the barrel sleeve back into the tool. It does need a good cleaning. Like I said, I like to test this tool more than some of the others. Oops. Put the detemp bearing in first. Even though with that extra weight of the spall reducer, the detent doesn't work very well, it doesn't hurt to have that in place. Alright, we'll put the piston in, and got a crush ring in there. We'll line the spall reducer up. There we go. And push that in until it catches, and that's where we want it. Yep. Now sometimes it'll catch wrong. It sticks up a little farther. That's not going to go into the housing. So you just need to turn it back until you get the right area to where it's relatively even with the surface there, the barrel. Okay. An interesting note, I worked for one of the companies that distributed this tool. Several companies over the years did distribute the HG100, and they used to break in this area from where the stop is to the end of the ejector slot on the barrel, and we always thought that it was defective. Well, on my last day working for that company, I did an HG100 repair, and out of curiosity, I did not reset the piston like you're supposed to using this push rod. I fired about 2 or 3 shots in it, and then pushed it back with the fastener, a 3/8 threaded stud I believe it was, and the push rod, and jammed it in there as hard as I could. And when I fired the tool, it broke that whole area out and parts went flying everywhere. And of course I told them, well, it must be a defective barrel again.